Today we're going to look at the rate at which objects sink. So what I have here is a water column of approximately 1.1 meter of depth. And our first objects are two spheres, both the same diameter, but one sphere is brass and the other sphere is aluminum. So the brass has a density of over 3 times the density of aluminum. And we're going to drop these in the water and we're going to observe which one hits the bottom first. And hopefully you notice that the brass hit the bottom first. The next thing we're going to do is we're going to take two steel spheres. So they have the same density, but one of the spheres is about twice the diameter of the other. And we're going to go ahead and drop those in the water and observe which one hits the bottom first. And hopefully what you observed is they hit the bottom at approximately the same time. For the first case, what you'll notice is that both the brass sphere and the aluminum sphere had the same buoyancy force, but the brass has a greater weight than the aluminum. And if you do the math, you'll find that the net force divided by the mass of the brass is going to be greater than the net force divided by the mass of the aluminum. Therefore, the brass will accelerate at a greater rate than the aluminum. Our second case, we've got our large sphere and our small sphere. And our large sphere has a larger buoyancy force, but it also has a greater weight. Okay? And if you do the math here, what you'll find out is that the net force divided by the mass for the large sphere is going to be the same as the net force divided by the mass of the small sphere. Therefore, they'll accelerate at the same rate.